Okay, in this video we're going to talk about question number 6 from the differential equations worksheet. So we're trying to find the particular solution for the equation dy dx equals sine x over cosine y. And they gave us the initial condition y of 0 equals 3 pi over 2. All right, so to start this problem, we do need to find a general solution, and we start that process by grouping our variables. So over here, we can see we have two fractions, so we should already have that little light bulb going off that cross-multiplying is a good idea. And our x's are opposite each other, and our y's are opposite each other, so cross-multiplying is a perfect start. So we're going to cross-multiply here. We're going to end up with cosine y dy equals sine x dx. Now all of my y's are together, all of my x's are together, and I'm ready to go ahead and just integrate both sides. So here we go. This is where it's important to remember some of those identities. So the integral of cosine. If I take the derivative of sine, it gives me positive cosine. So if I'm trying to integrate cosine, it's going to bring me back to sine. And the y is going to stay inside, sine of y. On the right, if I take the derivative of cosine, it will give me negative sine. That's a y, sorry. If I'm trying to integrate positive sine, the negative sign has to move onto my cosine answer. The negative sign has to be there somewhere in this pair of functions. So integrating sine, the negative sign is missing. It will show up on the cosine answer. So moving backward, it will get me back to cosine, but it's going to have to be negative. All right. So sine of y is negative cosine of x plus c. To move forward, we're going to go ahead and use our initial condition to figure out what c is. So we're going to have to plug in 0 for our x variable and 3 pi over 2 for our y variable. So if I plug in 0 for my x, it's going to go over here. Let's start on this side. We have the sine of 3 pi over 2. That's going to be equal to the negative cosine of 0 plus c. So let's figure out how to find the sine of 3 pi over 2. If I'm looking at a sketch of my unit circle, I start here, we're measuring with pi, so I had a pi in the number I'm plugging in, so we're measuring my unit circle in pi degrees, or pi measurements, not degree measurements. So over here on my axis, I'm starting at 0 radians. If I move halfway around my circle, I end up at pi radians. So halfway between those right up here, this is our pi over 2 radians. So if this is 1 pi over 2, this is 2 pi over 2, which is why it reduces to pi. And if that's 2 pi over 2, then down here, this brings us to 3 pi over 2. So right down here, that's our 3 pi over 2. And then if we kept going, we would get back to 4 pi over 2, which is 2 pi. So to finish the circle, we'd end up at 2 pi. Now, I'm looking for the answer for sine or cosine, which means I'm not looking at the measurement I put in, I'm looking for the answer I would get out, and that comes from my coordinate pairs. So the unit circle is called a unit circle because its radius is 1 unit, so it's 1 space. So if I'm on my x-axis, I've gone up and down 0, but I can move over here 1 unit. This coordinate at 0 is 0, 1, because I've gone 0 on the x. Nope, that's the opposite. It's 1, 0. Because I moved over 1 on my x-axis and I went up and down nothing. So I'm at the coordinate 1 for my x and 0 for my y. If I move the other direction, I'm still at 0 for my y, but this time I've gone -1 on my x-axis. So -1, 0 and +1, 0. If I start at 0, 0 and move up, I have gone 0 on my x-axis, but I've gone 1 on my y-axis. So I'm at the coordinate 0, 1. So if I go down this way, I will end up at the coordinate 0, -1. And these will give me the coordinates for sine and cosine. The reason they do is because cosine comes from my x variable, and sine comes from my y variable. So if I wanted the cosine of 3 pi over 2, it would be 0. We want the sine of 3 pi over 2, so that comes from my y variable, which is -1. So the sine of 3 pi over 2 is -1. And you should be able to know that just from those 4 coordinates on your unit circle. Now, to figure out what the negative cosine of 0 is, we should figure out the cosine of 0, and we just determined it right here on our unit circle. 0 is this point right here. This is my coordinate pair. I said that my x value is my cosine, and my y value is my sine. So if I want the cosine of 0, it's right there. It's the number 1. So this cosine of 0 is 1, and it has to be negative because of that negative sign. Now, you can also determine that the cosine of 0 is 1 using the hand trick. So if you put the 0 axis down in your hand trick, you've got 0 fingers left on bottom. That's your sine value. And on top, you have 4 fingers. So one of the ways to remember this is 0 and 1 are always paired. So if you've got 0 in one spot, you've got 1 in the other spot. So 1 is cosine. But if you can't remember that it has to be 1, you can just use the rest of our rule, which is however many fingers you have left, you take the square root of that number. So we have 4 fingers. Square root of that is 2. And you divide that by 2. So 2 divided by 2 gives you 1. Because all the values in the middle here are always square rooted and then divided by 2. Okay, so we've got -1 equals -1 plus c. So if we want to solve for c, all we have to do is add 1 to both sides. We end up with c equals 0, which is wonderful news because now we're ready to move on to actually finding our particular solution. So we're going to go back to where we were before we plugged in our values. So we have the sine of y equals the negative cosine of x, and then plus c is just plus 0, so I don't even have to write that part. The very last thing I do have to do, however, is solve for y. I want y by itself. So I want to undo the sign that's happening to y. And we undo sine using the inverse of sine. It means the opposite. So if I do the inverse of sine to this side, it will undo the sign that was already there. Y will be by itself. On the right, the inverse sign won't do anything to this negative cosine to cancel it out, so we're going to write both. We'll have the inverse sine, which we read as a little -1 exponent, of the negative cosine of x. There we go. And that is our particular solution for question 6. Question 7 we're going to do in its own video in just a second.